we will refer the Greibach normal form. It is a normal form wherein the productions are of the type either starting with terminal or containing terminal. Okay. So how to define them? The productions will have the form A gives beta B, where A and B belongs to V or N, that is variable or non-terminals. Beta belongs to terminal symbols, and this B is possibly empty. That means if B is epsilon, we have just left with one terminal symbol available in the grammar, or we'll have one terminal and all others as a variable. So this type of form is referred as Greibach normal form. So we need to convert all the grammars into this form. Greibach normal form have one type of left recursion which needs removal. That left recursion is represented in the form of A productions, wherein we say these are of the form A gives alpha 1, alpha 2, A alpha 3, A alpha n, or A gives beta 1, beta 2, beta m. If we have a recursion of this form, A gives A, left recursion, it is to be removed like this. A gives beta 1 B, beta 2 B, beta m B, where B is alpha 1 B bar alpha 2 B bar alpha n B. Okay, by using such a conversion, we can convert the grammar in left recursion into non-left recursive grammar. Okay, so let's go for conversion of this grammar, given grammar, into its equivalent GNF form. Step 1 is simplification of grammar. Which means removal of useless productions, removal of unit productions, removal of epsilon productions, and removal of useless symbols from the grammar. Okay, so let's go for removal of useless symbol. Do we have any useless symbol available here? S gives AVA, where A generates epsilon and B also generates epsilon. That means we do not have any useless variable here. Similarly, we do not have any useless production also. But we certainly have here epsilon production, which is removal. So let's go for removal of epsilon production, starting with the B. So focus first on removal of B gives epsilon. After removal of B gives epsilon, in the first grammar, we will have A or ABA. Okay, this would be from S gives ABA. Then from A, 0A bar epsilon. From B, we will have 1B bar 1. Because from this 1b, if this b is replaced with epsilon, we are left with 1. So in this way, we have removed b gives epsilon. Now it's time to remove a gives epsilon also from the grammar. Okay, so let's go for this. From here, what we will have s gives single a bar a bar. Both a is replaced with epsilon will give s gives epsilon bar ab bar ba bar s gives b. Next is a gives 0a bar 0, and this would be as usual 1b bar 1. This is a grammar when we have removed epsilon from a gives epsilon as well as b gives epsilon. But s gives epsilon is still there because this grammar is basically the grammar which generate epsilon strings also. Now next step is removal of unit production from the grammar. So what different unit productions do we have here? S gives A, this is one unit production. Similarly, S gives B, this is another unit production. So let's remove these productions. So replace them with their own respective grammars. We will have S gives 0A bar 0 bar AA bar epsilon bar AB bar BA. Similarly, S gives 1B bar 1. This is removal of first, second. A's production will remain as it is 0A bar 0. B's production will remain as they are 1B bar 1. Is this clear? Is this clear to all? So what next? Next is conversion of this grammar into equivalent GNF form because we have simplified the grammar and our simplified grammar is available with us. So let's look for, do we have any grammar which is in the form of left recursion? We have S gives start with 0, 0, A, epsilon, A, B. So this is not in recursive form, left recursive form. Similarly, A is also not in left recursive form. B is also not in left recursive form. So let's look for what are the production rules which are not in GNF form. So this is GNF, this is GNF, this is not in GNF, this is GNF, not in GNF, not in GNF, 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 and GNF. So basically just two productions are there which are not in GNF forms. That is S gives AB and BA. So we don't need this because we do not have left recursion. Then what do we have? We have the productions containing two variables which is not in GNF form, but the first variable which is available amongst these two productions are the variables which have their own production in the form of GNF already. So if we substitute them with that of their productions, we can very well get these two variables also, these two productions also in the form of GNF. So let's substitute. S gives AB, here this A will substitute with the productions of A. So ultimately 0A B or 0B. This is for this. Then for this BA, replace this B with its production. So ultimately 1B bar 1BA bar 1A. And the other production rules will remain as they are. S gives 0A bar 0 bar epsilon bar 1B bar 1. A gives 0A 0, B gives 1B 1. So this is a Greibach normal form equivalent to the given grammar. Any query or any doubt in this, please let me know. Should we go for the next example? Let's take this. So here, how many production rules we have? We have S gives AA, S gives A gives SS, A gives B. This is in GNF and this is in GNF. These two are not in GNF. Okay, they are not in left recursion form also. But if we substitute S gives AA here, we can get this in the left recursive form. Okay. Before that, we need to check for simplification of grammar. So step 1. Simplification of grammar. Do we have any useless symbols here? Answer is no. Do we have here any epsilon productions? Answer is no. Do we have any unit productions? Again, answer is no. That means this grammar is already in simplified form. The grammar is already in simplified form. What next? We just have two variables here. One is S and another is A. Let's convert one of them into left recursion form. S is a starting variable, so don't touch to it. Keep it as it is. S gives A bar A. But A is not a starting variable. So let's try to introduce left recursion here. How? We have S gives A gives SS and B this as a thing. So just replace this S with the productions available in A S. So A gives AAS bar AS bar B. Basically, this first S has been replaced with this and this. So as a result, we have this, wherein if you see, this A is in the form of left recursion form, where is A available here, and these two are already in GNF form. So we can very well write it in the form of generalized form like this: A alpha bar beta 1 bar beta 2, where beta 1 is AS, beta 2 is B. And it's time to apply this rule. Okay, that is, if this is the form, just make A equals to beta B and B equals to alpha B. Okay. Beta 1 bar beta 2 bar beta M and this is alpha 1 bar alpha 2 dot 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 alpha n. Let's go for it. Apply a production removal. So A gives alpha b bar alpha. That means this alpha is what? Excuse me. We had S gives A bar A gives AAS bar BS bar B. This S replaced with AA followed by AS bar B. Apply A production rules. There is nothing but A gives beta I, that is AS bar B bar AS B bar BB, and B is equals to alpha I. Alpha is what here? Alpha is AS. AS bar ASB. This is the conversion into the grammar which do not have left recursion. Here we have this, and this in the form of GNF now. Let's put or substitute A in B. So after substitution, we will have A gives AS bar B bar ASB bar BB, and B is equals to, just replace this A with these all. So ultimately ASS bar BS bar ASBS bar BBS. This is for first expression, first production rule. For the second production rule, now we will have this A getting replaced and this SB will continue further. So ASSB followed by BSB followed by ASBSB followed by BBSB. So ultimately what we did here, we kept this S and then this SB here and here respectively, and we replaced this A with all of the A's productions. Now after doing this, we have left only S which is not in GNF. So S gives GNF, that means what exactly? Substitute this A with that of productions of A. Ultimately, we will have AS from this A followed by this A. Next BA, next AS, BA, next BBA. So if you see here, all the productions which we have here are the productions which either contain A or B, that means a single terminal, or they start with the terminal symbol. This is our equivalent Greibach normal form grammar. What we did, we have seen the methods here for conversion into GNF, wherein in the first case, the solution was obtained simply by substitution. Whereas in the second case, we had left recursion available with us. So we solved the left recursion and then we substituted the values. So these are the basically ways to convert the given context-free grammars into equivalent Chomsky normal form and Greibach normal form. In any of the conversions, the first step is always to go for simplification of grammar first. Thereafter, if you are going for CNF, convert all the terminals which are associated with variable into equivalent variables, and then replace the production rules containing more than two variables into containing two variables by using dummy production rules, dummy variables. Similarly, in case of Chomsky normal form, we need to look for left recursion. In case of Greibach normal form, we need to look for left recursion. If left recursion is available, remove the left recursion by using lemma, and thereafter go for substitution in order to convert the given grammar into equivalent grammar containing productions, either starting with a terminal or containing terminal.